Okay, we want to find out if this diverges or converges. So with this one, what I would do is the limit comparison test. With the limit comparison test, you have your a sub n and your b sub n. Your a sub n is whatever you have originally, and your b sub n is something you choose. So what do you choose? You tend to choose whatever makes stuff cancel out. So with this, you would probably do 1 over n. You would do 1 over n because that's what this is reduced to its essence, right? Like if we just had no subtraction and no addition there, it would be 1 over n reduced to its essence. That's what you would have. So a sub n is that, and then with our limit comparison test, we divide. We divide, right, like that. So that's the same as multiplying by the reciprocal. And we take the limit as n approaches infinity. We take the limit as n approaches infinity, and we hope that this isn't 0 or 1. That this is not 0, that this is not 0 or infinite. So it could be any other number, any number whatsoever, besides 0 or infinite. Infinity is not even a number. So that's our goal, to get that. So if we get that, then we can say that whatever happens to b sub n also happens to this one. So if b sub n was to converge, this would converge. If this was to diverge, this would diverge. And we know already what happens to this because this is 1 over n. So we know that series diverges. We know it diverges because this is a p series with p equal to 1. P equals 1, and if you have 1 or less than 1 in a p series, it's going to diverge. It's also called a harmonic series, and you should know that it diverges. So now we can do this multiplication here. n² minus 1 over n³ plus 1. This is all multiplied by n, which gives us n³ minus n. n³ minus n in that numerator. Now we can divide everything by n³, and that's going to give us 1 here, because n³ over n³ over n³ gives us 1 again. This is 1 over n³, and this is negative 1 over n³. Negative 1 over n³, we plug in infinities, and this goes to 0. So we add 0 and we subtract 0, which gives us 1. So that equals 1. And so remember, we wanted to get any number, and we did. We got 1. That means that whatever applies to this one also applies to our a sub n, to our series with a sub n in it. So that means that diverges. That diverges because we know that when we have the series with b sub n to which we're comparing it to, that diverges. And since we got a number, this must also diverge.